Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Leaving group ability in nucleophilic substitution, SN1, SN2, depends on the stability of the departing anion. A more stable, weaker base, anion is a better leaving group. Stability is governed by 1. Inductive field effects of electron withdrawing groups, 2. Resonance delocalization of the negative charge, and 3. The pKa of the conjugate acid. Lower pKa of conjugate acid is equal to more stable anion is equal to better leaving group. Step 1. Analyze anion I, CF3SO3- triflate. The CF3 group has 3 highly electronegative fluorine atoms exerting a strong electron-withdrawing inductive effect, combined with the 3 oxygen atoms of the sulfonate group delocalizing the negative charge over 3 oxygens. Triflate is one of the most stable anions known. Conjugate acid, triflic acid, has pKa-14. Triflate is the best leaving group. Step 2. Analyze anion 2, C6H5SO3- benzenesulfonate. Benzenesulfonate also has 3 oxygens delocalizing the negative charge, similar to triflate, but the phenyl group is electron withdrawing by resonance yet not as strongly withdrawing as CF3 by induction. Conjugate acid, benzenesulfonic acid, has pK-1 to -2. Benzenesulfonate is an excellent leaving group, second only to triflate among those listed. Step 3. Analyze anion 4, CH3CU- acetate. Acetate has resonance delocalization of the negative charge over 2 oxygen atoms, carboxylate resonance. Conjugate acid, acetic acid, has pKa 4.76. Acetate is a relatively poor leaving group compared to sulfonates, but still better than phenoxide because carboxylate resonance provides more delocalization than phenoxide. Step 4. Analyze anion 3, C6H5O- phenoxide. Phenoxide has resonance delocalization into the aromatic ring, but the negative charge is primarily on oxygen with partial delocalization into the ring. Conjugate acid, phenol, has pKa 10. Phenoxide is a stronger base than acetate and therefore a worse leaving group. Phenoxide is essentially not a leaving group in SN2 reactions on sp3 carbons. Step 5. Rank leaving group ability, best to worst. I. Triflate, pKa of conjugate acid -14, 2. Benzenesulfonate, pKa -1, 4. Acetate, pKa 4.76, 3. Phenoxide, pKa 10. This gives the order I to 4, 3. Why other options fail? A. I to 3, 4 places phenoxide above acetate, which is wrong because acetate, pKa 4.76, is a weaker base and therefore a better leaving group than phenoxide, pKa 10. C. 4I to 3 incorrectly places acetate as the best leaving group. D. 4, 3 to I is entirely reversed from the correct reasoning. Therefore, the correct answer is B. Therefore, the correct answer is option B.